Okay, and I hope we're all back and we can get your attention again. Another year, another Clojure conference, and once again, I am blessed to be announcing Paula today for us. I did so last year as well, and I think the year before that too. 2 years before, okay, I stand corrected. Paula is usually known for her talks on data storage, but today, let's expect the unexpected and go for something completely different. We have both exchanged fond memories of Perl, and Perl is known for, also known for doing weird things on the language level. And there was a tool, a package called Acme Morse back then, and I think this is the port to the modern world. So let's get Acme Morse for Clojure. Paula Gearon.
Thank you, everyone. This talk is about a joke. I was making a joke that the talk was a joke, but really it just amused me, and because of that, you're all going to have to sit through it. It's about remorse, an exercise in perversity. One morning, I was looking at Slack and saw that Michiel, Borkent, was extending BB to work with keywords compatibly with Clojure, and had discovered that keywords could have periods in them, which had been unexpected and I believe wasn't supported in earlier versions of Clojure. And because of this, he makes the comment that you could make some ASCII art this way. And Lasmata at the bottom here said that perhaps something that encodes normal keywords into Morse code keywords. So SOS would be ... .. So I got to thinking, this shouldn't be too hard to do. I went and found I went and found a page online which described each letter's being converted into Morse code. Turn this into a map, A to Z, A to Z, into Morse. And you'll notice at the end here I have various symbols. They weren't there to start with, but putting all of these in, I then created a reverse map and put together a few functions. You'll see at the top there, string to Morse, that takes a string, converts it to lowercase, runs it through the map, joins everything with underscores. Morse to string, splits it up on underscores, runs it through the map, and applies string to the result. Convert keyword is a tool that the keyword to Morse and Morse to keyword both use, which are going to turn is going to help you take a string, a keyword using ASCII text, convert it into Morse, or take a keyword using Morse and convert it into ASCII keywords. I then announced it. Borkdude says, amazing, I had to try this with Babaska. I was given the recommendation that it should have been called Remorse, which I loved, and changed the name of the library. And I was particularly taken with Alex's final comment. After renaming to Recourse, Alex came up with this. Seems like you changed horse mid-course without recourse. So then, because I added in those extra characters, the quotes, the parentheses, etc., I changed it from A to Z, or Morse to A to Z, now just Morse to C for character. I then decided to create all of the maps in a single expression here. So starting with the first map, which is C to Morse in the middle here, running the reduce over it so it only runs over the map a single time, I created functions for moving into from ASCII into Morse, Morse back to ASCII again. And you'll notice also that I have this version where I'm replacing dots now with this character, Unicode B7. That's still in the ASCII table, but it turns out that symbols cannot have dots in them. And I thought, why not take this beyond keywords and into symbols as well? B7 is the middle dot character. And since it's still under 256, it's still in ASCII. This works nicely with any sort of text editor. So updating the code a little bit, now I introduce this symbol to Morse at the bottom. And I can go back from Morse back into symbols as well. So consequently, if I run symbol to Morse over the symbol hello, I get Morse code out, exactly as I was hoping. And you'll notice now I have middle dots in the symbols. But then it occurred to me, since I can now convert symbols and keywords and strings all into Morse code, I could apply it to the code itself. So for people who are familiar with the expression dogfooding your code, I decided, why not use remorse on remorse? So let's start by defining something called def macro, and it just takes the forms for a macro and applies def macro to it. Now, this isn't going to work exactly as is. I'm showing it this way because def macro is now being written in Morse code. It's exactly the same operations, except the symbols have been renamed. We can do the same thing with def. But we can do it with the def macro at the beginning of the line. Similarly, we can apply this to function, let, defen. And we can now run over all of the functions which we use to generate the Morse code and to convert it back again. You'll notice off on the side here that I've included Clojure string as ... So things like string join or string split is now ... split or ... join. Running through the rest of the code, it was a lot of manual work. Why not write a little bit of code to Morse, which takes Clojure structures, written as, it's homoiconic, and just feed those structures into this function. It'll run over it, run code to Morse for everything. And with this function here, I can just feed the program into itself and get out the Morse code equivalent. If you want to run over things like macro readers, for instance, a function like string5, you'll see that macro readers actually expand into their list equivalents. So if a macro reader was fed into this function, this is going to work just fine. Okay, so let's look at some of the original structures that I had from earlier on. Run it over, and I end up with structures all written in Morse code. Finally, I can define the symbols that I want to export for people using the library into their Morse code equivalents. But that data is redundant. Why? If I go back a moment, see the string to Morse here is being defined as string to Morse in Morse code. It's the same data, but one time in ASCII, one time in Morse. So what if I create a macro which takes the Morse code, converts it back into its ASCII equivalent, and then define that ASCII to the Morse, which is what we were doing on the previous line. Of course, this has to be written in Morse. So all of these definitions can now be rewritten using that macro like this. the final file. So I'm done, right? But what about ClojureScript? So ClojureScript code, when it's compiled, runs through the ClojureScript compiler, which is a Java process. This Java process reads the ClojureScript and emits JavaScript. What's printed out has no JavaScript in it. Usually, we do have self-hosted ClojureScript, but I'm not going to go into some of the intricacies there. The general process, though, is ClojureScript in, runs through this Java compiler process, JavaScript out. But macros are a little bit different. They have to be run during the compilation step. Macros get run in Java itself to generate ClojureScript. So when we have macros, they're going to come in Clojure code, execute in a Clojure system, emit ClojureScript, which then goes through the ClojureScript compiler, and that will emit the JavaScript. I'm putting dashes up here. Again, you don't use def macro on def macro, so the dashes here are to explain that it's something different. Instead of dash def macro, it will be the Morse equivalent. If we're doing, these are what I call the bootstrap macros. These are the things which set everything up to make it all run. Now these, because I'm defining macros, these are things which need to run in Clojure. But all of the functions which we want to be able to export and allow people to use, for instance, string to Morse, these are all going to be in ClojureScript. Now, if we consider those export macros, the ones which took the Morse code and defined it to be equal to the ASCII equivalent, because it's a def macro, it has to run on the JVM. The Morse to symbol here is going to be evaluated during compilation, which is on the JVM. But that def that's being emitted, that's ultimately destined to be compiled, and it'll be evaluated in the JavaScript runtime. So we've got a mix happening here. So going from the top, we've got the bootstrap macros. We've got the Clojure to Morse and we've got the ASCII to Morse and Morse to ASCII translation code. And then we need to emit that public API. But to export that public API, we need these export macros. You'll see that the translation, Morse to ASCII, ASCII to Morse, that's occurring in ClojureScript, and that translation needs to be used by the export macros, which are then going off to ClojureScript. But we can't really go from ClojureScript back to Clojure, out to ClojureScript again, because once we've emitted something as ClojureScript, it's destined for JavaScript. It doesn't have access to the Java runtime. So having ClojureScript at that step in the middle isn't going to work for us. But we need it there because that's what we're going to be publishing. So instead, we need the translation code duplicated over here as Clojure code. That can then be used by the export macro to create the public APIs. So that middle arrow going to the right ought not to be there at this point. However, instead of ClojureScript and Clojure, we can rename now to just CLJC, which means we can use the same code here, and it's a single file doing both jobs. As a result, we've got this Morse.cljc, which is doing the translation. It's going to be used both by the Clojure compiler as it runs through to create the macros and allow the macros to run. And then it's going to be used as the data that's being exported and compiled in JavaScript to be accessed as a library. So it's going to be used in both ways, but we can use a single file with cljc. And so each step of the compilation will see that file under different circumstances. One of them will see it as CLJ, the other will see it as CLJS, and we'll end up compiling that same Morse.cljc namespace with both the Clojure compiler and the ClojureScript compiler. Finally, we've split it all up now. Here's what the whole thing looks like. It's a little bit messy. The documentation on the namespace and the author is still in ASCII, but almost all of it's in Morse code. As an example to show that it really does work, let's see if I can make this a bit bigger. Okay, if we let's try this under Clojure. If I want to do a require, I can bring in remorse.core as RM. And let's run rm string to Morse on hello world. And I get Morse code back out. Now I can try the same thing under ClojureScript. Takes a little bit longer requiring it. And again, string to Morse on hello world. And I've got the same output. I'd like to return to this. And while it's a bit small here to see clearly in the audience, at no point in any of this code does string to Morse appear anywhere. It's all written in Morse code. It decodes itself as you load the namespace. It looks like when you require it, it looks like any normal namespace with normal functionality. It's just going to be a surprise for anyone who opens the source files. So thank you very much, everybody. And I tried to finish up early. If anybody has any questions about this, I mean, I don't know why you would, but
yeah, we can take a question or two.
Yes.
How long did the adventure take from start to finish?
The first part took about 15, 20 minutes. The Clojure step where I compiled everything in itself took an hour or two, 2 hours maybe. And then I needed a day or two to get my head around what was going on when I tried to move it into ClojureScript. I needed to go through the different files where I started with the bootstrap and then having the file compile under both CLJ and CLJS as a CLJC file, and then creating the output as it was. I had a number of long discussion with Mike Fikes about what was going on with the macro compiler, and it sort of bends the brain a little bit. We both kind of knew what was going on, but you really needed to get your head around it properly to know like what you should be doing to split this up the right way. And we finally got it to that point, and we're very, both of us were very happy with the way it came out. So I should thank Mike for working through it with me. Yes?
When can we expect this in Clojure?
Hang on.
When can we expect this in Clojure Core?
A few weeks after releasing this, someone got in touch with me and told me that he had a need for Morse code. in a project that he wanted to work on, and that he felt that this was the project that he had to work with. And so, so I've been told it's going to have real-world applications. This terrifies me.
So just to understand it, you don't have the readable source code anywhere, and if you want to extend this, you need to translate this back to something
The
that's
function
readable?
that I showed earlier, which could convert source code into Morse code source, a similar function, an almost identical function, will convert from Morse code source back into ASCII. And I normally define those functions at the REPL, and I just feed things in. So when I want to edit it, I feed it in, get it back out as ASCII, edit it, get it working, and then convert it back and put it back in the source file.
Yeah, the really small one. Is it possible to make custom cipher table to make not Morse, but anything I like?
There's no reason you couldn't. It's just a simple mapping of characters to a code, and some of what I showed earlier shows how I take that mapping and I reverse the mapping. The reason for having 4 different tables, all of them based on the first one, but the initial table, which is defined as a map, the next one was just a reverse of it, and the other 2 were exactly the same, but converting all of the periods, full stops, into middle dots for use in symbols. It's completely agnostic, so long as you're not creating any kind of code which will lead to ambiguities going to and from. It shouldn't be a problem at all. I was using underscores to separate characters, and I should note that when I went to ClojureScript, it turns out that ClojureScript vars cannot begin with a dash. And so in the ClojureScript version, symbols have to be preceded by an underscore if they were to begin with the dash otherwise.
So this started out with learning the interesting fact and maybe unexpected fact that dots are allowed in keywords. And did you learn anything else interesting? And finally, did you also learn Morse code during this project?
I got better with Morse code. I started editing things and putting the codes in directly because it was a hassle to put things to dump it into the function and pull it back out. I was often you may have seen the ASCII versions of it. I'm using a lot of vars, which are just single characters. And so I started learning, and I've forgotten most of them now, but I started learning which sequences made up each letter. But I was also finding that I had to read things and know what I wanted to decode, and I found that I was getting better and better at reading it as Morse code, just so that I'd know which function or which block of code I needed to modify. So rather than decoding entire functions, I would often find the function I wanted by reading the Morse code, find the section, and just decode that part to modify and re-encode. And occasionally I was able to encode it as dots and dashes. But
Okay, so that's it for today. I've been told that there's a method called the Koch method, which is supposedly the easiest and fastest way to learn it. But maybe it's faster and easier to build your own Morse library. Once again, big warm applause.